Hey there, welcome back to another video by ChemEnggLife. In this video, we bring to you a new material balance for a mixer. In our previous video, we wrote a Python code that calculated the simple material balance for a mixer with two streams that were coming in and one stream was going out. It was a very simple case and it only worked for two streams. In this video, we are going to be looking at a scenario where you have n number of streams. That means it could be 10, it could be 50, it could be 100. So we would like to write a Python code that calculates the outlet concentration and the outlet flow rate for n number of streams. Now, obviously, the outlet flow rate can be calculated as the sum of the incoming flow rates of all the streams, whereas the concentration is calculated as the sum of the product of the flow rate and the concentration of each stream divided by the total outlet flow rate. So what we're aiming for a Python code is that the user gets to decide that how many streams they have, and we can use a loop setup where Python then automatically calculates the output for the n number of streams. So at the end of the day, the user does not have to actually manually write the data for each stream. So that's what we're going to be doing. And for the code, to make it very simple, we are going to assume the exact same as before: perfect mixing, steady state, and constant flow rate. So let's begin. Yeah, so just like explained, we are now going to write the code for a material balance for a mixer where the user can tell Python how many incoming streams there are. So the first thing is that we need to define the input from the user. Input from the user, and that is what we're going to call n. Then we're going to write, first I'm going to write input. Then I'm going to say how many number of incoming streams into the mixer. Now the thing is, and just like I explained in my previous video, that when you write the input function, the input that you provide as a user, it is stored as a string. Like, for example, if I was to run the code and I was to write 5, then you can see in the variable explorer that it is actually stored as a string. That is quite frankly not very helpful, because when we are about to run the loop, or when we are going to be performing any numerical operation, we can't actually use the string for anything. Therefore, the string actually has to be changed to an integer, and luckily we can do that with a very simple function called int, and you just write that in the beginning of your input. So you write int, which is basically integer, and then you include your input function within that function. So now if I was to run it and I was to write 5 again, then you see that now it is stored as an integer, and we can now then run loops with an integer. Just keep in mind that if you're about to run it, then you should remember to use the integer. Anywho, and then now we are going to jump into the loop system. So within the loop for the mixer, but before we begin the loop, we kind of have to define a value, and we are about to calculate f out, and that is 0. I'm going to call it 0 because when I run the loop, I'm going to cumulatively add stuff into it. So therefore, before we provide that variable inside the loop, we need to define a value for it beforehand, and that will be very clear to you in a minute. The second variable that we're going to define first is C01. When we have to calculate the outlet concentration, the outlet concentration is the sum of the molar flow rate multiplied by concentration divided by F out. Within the loop, we cannot really perform the division, so we can only calculate the sum of the numerators. So C01 is actually the numerator value that we are going to be inserting in the final equation. But like I said, it will be quite clear to you once we are running the loop. Great. But then now we will start writing the loop value, and we are going to be using the for loop. So there are two types of loops that you can run in Python. There is a while loop and there is a for loop. The while loop is something very different. That is a loop that keeps on running until a condition is met. But when we already know the iterations beforehand, then it makes sense to use the for loop. So the line that you need to write is for I in range n. So what this sentence actually means, that the loop is going to run for n number of times. And what is n? N is the thing that we have defined right here. So if this was 100, that would mean that then you would actually be running the loop 100 times. If the n is 5, then the loop will only run 5 times. So that's basically, an I is just something that we write. It's basically an iteration. So what we're saying is that for I in a range n, like run this in the range of this many times. You could actually have just written a number here as well. For example, if you would like to run a loop only for 5 streams, then you can also provide the number here, which is 5. But the reason we're using the range n is because because the user has provided the n value in the very beginning. Great, but then we're gonna write print, and this is something to let the user know about what value it is that they are providing. So you are gonna write f, and then I'm just gonna write oops, sorry, there. Wait, what happened? Sorry, there we go. Then we're just gonna write n, and this n is basically just sorry, there we go. So then the very first line that we're gonna write is just to let the user know that what stream it is that they are working with. So then I'm gonna write I plus 1, and just a bunch of lines in the end as well. Now, the reason I'm writing the 1 plus 1 here, this I is basically the iteration value. So for example, that when the first iteration is being run, then it would have the value of 0. In Python, it does not start from 1, it actually starts from 0. So that means that if you're running an iteration 100 times, in Python world, you're actually running it 99 times. Because when you start from 0, obviously you are one number below. So therefore, I write plus 1, because when the user runs it, oops, I should not have done that. When the user runs it, then you will be given the actual value. So that means that if I don't write plus 1, then Python will ask me the molar flow rate for a stream 0, which in our papers would be stream 1. You can obviously also do it the other way around. So if you are comfortable working with starting from 0, then you don't have to write plus 1. But me personally, I always start from 1, especially in all of the material balance problems that I have encountered. You always start from 1, right? You never have a stream 0 or anything. So therefore, it's always a good idea to keep that in your mind. So now we are going to write the very first value, and that is the molar flow rate. So I'm going to once again ask the user, to provide us the molar flow rate value. And then I'm going to ask the user to also give me the concentration value. Concentration of the stream. There we go. Now, just like before, earlier we used the integer function to convert the string into an integer value. But now we are actually using a float function. And just like you can see in the pop-up, it actually converts the string into a float data type. A float is basically like a decimal data point. So that's what it does. So now, so far, when the loop begins, for each iteration, we will be shown this print value, that what stream it is that we're talking about. The user will be asked for a molar flow rate, and he or she will be asked for a concentration for the specific stream. Now comes the interesting part. What exactly do we want to do with the flow rate and the concentration value? Well, the first thing is that we can actually calculate the outlet flow rate, because that is basically just the cumulative sum, right? That's just the sum of all the flow rates. Then in Python, there's a very smart way of doing it. It's called this. So what is happening now? Do you remember that in the very beginning we defined the f out? That is defined to be 0. What the plus equal sign means, that for every iteration, this f value is added onto this variable. So that means that, but in order for us to use this, we have to define that beforehand, which we did right here. So when Python runs the very first iteration, and let's say the f value is 10, that 10 will then be added to f out. When the second iteration is run and you provide the second value of, let's say, 20, that 20 will then be added to the value of f out. And it will continue to do so. So by the time the iteration ends or the loop ends, you would have added up all of the f values that you provided in each iteration. So that's what plus equal to means in Python. A very helpful tool, but the only condition is that you define this variable beforehand, before you run your loop, and then you have to define that as a 0 first, because if you don't define it first, then Python doesn't really know where it should add the iterative value. And then we come down to the C01, which is actually the same, but in this case, it is the sum of the product of f and c. So therefore, this time we are going to write plus equal sign f multiplied by c. And do bear in mind that these two numerical operations, they are done for each iteration. So that means that when I am on iteration 5, Python will only multiply the f and the c value of that iteration. It will not multiply the previous one or the one after. It will specifically only multiply those two numbers and then add it up to the previously summed value. And that actually makes your life a lot easier, right? And that's what I said in the very beginning. That is why we have the C01, and that is the numerator of our fraction in the C outlet. Now, another thing that you must remember for loops is that if you don't know how the loops work, then very briefly I can tell you that this is the entire loop, right? So Python starts from here for each iteration. That means that for stream 1, Python will then it will show you this value, ask you for f and c, add the f value into the previous f out, calculate the product, add that into C01, and then it will just go to the beginning again, and again, and again for n number of times. So if the n was 100, Python would do this 100 times before ending the loop, hence the name, the loop. If it is 1, it will only do it once. If it is 500, it will continue to do so 500 times. Now, obviously, in our case, since we are providing the value in each iteration, so obviously running it 500 times sounds quite a lot. But on the other hand, if you already had data and you are just iterating it through it, then obviously, it makes your life a lot easier in Python, because then you can just decide to do it as many times as you like. So that's basically what a loop does, and that is a for loop. And let me just remind you again that there are two types of loops in Python, the while loop and the for loop. In this case, the for loop makes a lot more sense. But we're not done yet, right? Because we still need to calculate our outlet concentration. Now, since the formula, like I showed you earlier, we already know the C01, and then we just need to divide that by the outlet flow rate. So that's essentially actually it. So now we have calculated our f out, which was part of the loop, and then we have calculated the outlet concentration, which is basically just the division of C01 divided by f out. And then obviously we need to show the answers to the user, and then we are gonna print out the value. We're gonna write that total flow rate is, and then a bunch of curly brackets, and then we're gonna write f out, and then I'm gonna take that in 2 decimal places. On the other hand, I'm gonna say f again, and n. Oops, sorry, not n, because then we just want to go with the f. Then I'm gonna write total outlet concentration is, and then in this case we are going to use the cout variable, because that's where we have the value, and I'm going to write that in 4 decimal places. When you use the f in the print functions, it is the reason we do it is because we want to insert an integer value into our print function. If you were doing so with a string, then obviously you cannot use the f. For string, it's a bit different. But when you have these values or integers stored in your variables, you can actually use the f in the beginning, and then in the curly brackets, you are then allowed to insert your outlet value. And why am I getting an error? C out. Oh, sorry. Yes, I am supposed to write a small o. There we go. And that's actually very good because in Python, if a capital and a small, there's a huge difference. So if I was to write a C capital O, it's not the same as lowercase out, right? So that's just, well, luckily you just got to see that as well, that if you make that mistake, then it's wrong. Anyhow, so now we can actually run our entire code. I'm just going to remove all of my variables. Clear. There we go. And not to sound too paranoid, but in order for me to check my Python code, I actually did run the material balance in Excel. And you can see the Excel table right here on the screen. So now what we're going to do is we're going to test for a few streams. So we take a very simple example. Let's say 2 streams to begin with. And then you see, now we are in the first iteration. Python is asking us for stream 1. And we need to give the molar flow rate. Let's say that is 24. And the concentration is 2. For the second one, it is 16. And for the concentration is 1. So before I press enter, you see, so now it's stream 1, stream 2. And then we search for it. And then the total flow rate is 40. And the total outlet concentration is 1.6. Let us compare that with Excel, and there you go. As you can see that in Excel, that the outlet concentration is indeed 40, and the outlet concentration is calculated to be 1.6. So our Python code works for at least 2 streams. And I will just put a space there so that these 2 strings are aligned. And let's run it again with 5 streams now, because that's why we are here, right? So let's say that now I have 5 streams, and I'm going to do 24, 2, 16, 1, 15, 4, 14, 3, and 24, and 1. There we go. Now the total outlet concentration is calculated to be 93, and the outlet concentration is 2.0430. Well, that does not align directly with what we have here. So that means there is indeed something wrong. Did I insert 2, 4? Yep, sorry, my bad. I am the one who made a mistake as compared to the Excel value. You see, I wrote 4 instead of 1. So my bad, sorry. But we'll just have to redo that. But you see, but again, you know, it's a very good idea when you're running these Python codes is that you actually run them in Excel on the side, because then it allows you to make sure that you are actually calculating it correctly. So I'm going to write 16.1, 15.4, 14.3, and 24.1. There we go. Now it actually fits perfectly. 2.0430, and the flow rate is 93. Yep, so you see, so that means that our code actually works as it should. So now the benefit of this code is, in comparison to the previous video that we made, is that you can actually choose how many streams that you have incoming. You can even throw in 100 streams, you can throw in 50 streams, or how many you like, and you don't have to customize your code for it. And you can it'll run the loop, and it will allow you to calculate the material balance. And better yet, you can actually use the similar setup for any other unit operation that you are working with. If you have a reactor, if you have a distillation column, or if you have a mixer like we did, or you have a membrane separation, or whatever the case is, you know, because when you're calculating the material balance, you're always going to have a situation where you have more than 2 streams coming in at times. So that is like a very quick way to write a loop function and how to apply that to a mixer so that you can run it for multiple streams coming into a mixer operation. Cool. Yeah, and also do check out our previous video where we did solve a very simple case of a mixer, where if you're interested in knowing how to set up a material balance only for 2 streams, then you can also look out for that video, and that would probably explain that a bit better. Great. But once again, thank you so very much for watching the video, and I hope you learned something new today. And if you may have any other question or any other doubts, feel free to reach out to Chemical Engineering Life anytime. And also, do not forget to like, share, and subscribe to Chemical Engineering Life channel for more videos. Thank you, and have a great day.